2.2, distance and midpoint formulas. Example 1, use the Pythagorean theorem to find the length of the line segment shown in the graph. Well, Pythagorean theorem works with right triangles. So let's draw in this right triangle right here. If you could see this right triangle, I think it'd be kind of easy. You need to know the length of the two sides to find the length of the hypotenuse. So we can kind of count 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, we want to find the hypotenuse of that. So we know Pythagorean theorem is a squared plus b squared equals c squared. That's going to be 8 squared plus 8 squared equals c squared. That's 64 plus 64 is 128. 128 equals c squared. So c is going to equal the square root of 128. Square root of 128. So we can break that down. Square root of 128 equals square root of 64 times square root of 2. That's going to be 8 times the square root of 2. So the length of that hypotenuse is 8 times the square root of 2. Now, we're going to learn a new formula. We're going to learn the distance formula. And basically, the distance formula is kind of a modification of the Pythagorean theorem. It's a generalization. So write this down. D for distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Notice all of that is underneath the square root. Notice those subscripts, x2, x1, y2, y1. Those are just x numbers and y numbers. And so example 2 says use the distance formula to find the distance between those 2 points. Well, you may notice those are the same 2 points that were shown in the graph. So we already really know the answer from Pythagorean theorem, but now let's do it using the distance formula. So I think most of you know this, but you're looking at an xy point and another xy point. So the 2 and the 1, that's just from this being the first point and this being the second point. So if I'm looking at the distance, the formula says take the second x, which is 3, minus the first x, which is -5, and take the second y value, which is 4, minus the first y value, which is -4, square it. Minus minus is going to be plus, that gives me 8. Minus minus is going to be plus, that's going to give me 8. So notice we have a couple of 8s there. 8 squared plus 8 squared is 64 plus 64 is 128. We have that square root of 128 again. Breaks into square root of 64 times square root of 2, or 8 times the square root of 2. So if you think about it, all that formula does, people get confused by that formula, but all that formula does is it literally tries to find the distance. You're trying to find the x distance, and then you're trying to find the y distance, because basically you're trying to do the Pythagorean theorem. The square root is how you find that hypotenuse. If sides A, B, and C of a triangle satisfy a squared plus b squared equals c squared, then the triangle is a right triangle. So we're going to use that Pythagorean theorem to figure out if it's a right triangle or not. Number 3, are the points 0, -2, 5, 1, and -4, 3 the vertices of a right triangle? Question mark. So we can look at this, and looks can be deceiving. You look at it and you're like, well, I don't know, it doesn't really look like it. Maybe that's a right angle, but we can't really tell. We can use distance formula and Pythagorean theorem to figure this out for sure. So what we're going to do is we're going to find 3 distances. So let's look at this. All right. Now, I like to shortcut the distance formula if I can. If I don't have to remember this whole thing, I won't. I'll just think about it as x distance and y distance. That's what I'm looking at. Okay. So here's your shortcut for this problem. Look at your x numbers, -4 and 0. Just look at the x numbers and that's it. The distance between those two x numbers, -4 and 0, is 4. Now look at your y numbers, +3 and -2. +3 and -2, the distance between those two numbers, +3 and -2, if you think about, here's 3 and here's -2. That distance right there is 5. So yes, we're subtracting the two numbers. That's what the formula says to do, but a lot of the times you can just see that in your head. Okay. So 4 squared is 16, 5 squared is 25. Add those together, you get 41. We're looking at the square root of 41. That's the length of that segment, square root of 41. Now we used the formula, but kind of just used it in our heads. Now let's do this one. Same thing. Just look at the x numbers. -4 and +5 is a distance of 9. And 3 and 1, that's a distance of 2. Yeah, you're subtracting, but I don't really care about that. We can do it in our head sometimes. 81 plus 4 gives me 85, so I'm looking at square root of 85. Third segment here. Look at the x numbers, 0 and 5. Find the distance between 0 and 5, that's 5. -2 and 1, the distance between those two numbers is 3. So square root of 25 plus 9, that's square root of 34. Okay, so we just used the distance formula 3 times to find those distances. But now we're going to use this statement right here. If we can satisfy a squared plus b squared equals c squared, then it's a right triangle. So one common mistake that people make is they forget to square it. All right, but you're looking at squaring those numbers. A squared plus b squared equals c squared. Now you look at the 3 numbers, and it should be obvious which one is the hypotenuse, because the hypotenuse has to be the biggest one. So we are going square root of 85 over here squared. And it doesn't really matter which one's A and which one's B. Doesn't matter, as long as you've got the two small sides together. Now, remember from algebra class, when you square root squared, it goes away. And keep in mind, this is a question. We're asking ourselves a question. Is this true? Is this true? 34 plus 41. 34 plus 41. Ooh, that's 75. Okay, that's 75 equals 85. That's false. So this right here doesn't hold true. That's false. So that means RST is not a right triangle. Three points are collinear if the sum of the distances between two pairs of points is equal to the distance between the remaining pair of points. Okay, so in geometry class, you probably learned this, and I used to teach this as this piece plus this piece equals the whole thing, or part plus part equals whole. But you've got, I think it was called the segment addition postulate. You've got a piece plus a piece equals the whole thing. So let's find the 3 individual pieces. First of all, we've got PQ. We want to find the distance between P and Q. So look at P and Q. That's these two. And again, we're going to find that distance. So we can call it, let's call it absolute value of P. All right. Absolute value usually denotes distance. So look at your x numbers, -2 and 0. The distance is 2. Look at your y numbers, 5 and 3. The distance is also 2. And yes, I'm subtracting them, but I'm just looking at the distance. Talking about distance, we've got 4 plus 4 is 8. That's the square root of 8. Okay. Now let's look at this piece, QR. QR, right here. So I guess I should have called that, instead of P, I should have called that PQ. PQ, here, let me fix that. That's better. So now this one is going to be QR. And again, we're going to go distance between the x's. 0 plus 8 is 8, or 0 minus 8, whatever. It's a distance of 8. Distance between 3 and negative 5 is also 8. So we've seen this before. That's 128, square root of 128. And you could find that decimal if you want to, but we don't really need to at this point, I guess. But now we need the whole thing, PR. We need the distance from P to R. So from P to R, you're only looking at, these two. So PR. The distance between negative 2 and positive 8 is 10. The distance between 5 and negative 5 is also 10. So that's going to be 100 plus 100 is 200. That's the square root of 200. Okay. Now, people are going to mess this one up because they're going to do what we did on the last one, and they're going to just ignore the square roots, and they're going to say 8 plus 128 does not equal 200. But that would be wrong. Okay. That's not what we want. We want the square roots. And I don't know about you, but I don't know what the square root of 8 is, and I don't know what the square root of 128 is, and I definitely don't know what the square root of 200 is. But you've got to ask yourself that question. Okay? So I might want a calculator for that. Let's think about the square root of 8. Square root of 8 is 2.82. Square root of 128 is 11.3. And square root of 200, 14. Okay, think about that. 2.828. So 2.828 plus 11.314 equals 14.142 question mark. All right, so what do we have? 2.828 plus 11.314. Yeah, that looks right. Once you look at the square roots, that looks right. And keep in mind, I rounded off, so it's not going to be perfect unless you use all of the numbers there, but that works. That's true. All right, so what that means is P, Q, and R are collinear. Linear means line. Collinear means they're all on a line. P, Q, and R are collinear. Midpoint formula. Here's another one that people kind of mess up, but use your head. We're trying to find the middle of the X numbers, and then we're going to find the middle of the Y numbers. A lot of the times you can do that in your head. Midpoint. Don't get bogged down in what the formula says. Just use your brain. Use your common sense. Okay. So number 5, find the midpoint. If I follow this formula, it says we're going to have x1 plus x2 over 2. That's negative 9 over 2, comma. Then we're going to have y1 plus y2 over 2. That is negative 5 plus 13 is 8. So we can reduce fractions, reduce them if you can. Always reduce if you can. Negative 9 halves, comma 4. That's the midpoint. And that's easy enough to do using the formula, I think, but it might be even easier sometimes if your numbers are easy, okay? Because really all we have to do is take these two x numbers, tell me what the middle is. You can find the middle of those two numbers and say, well, the middle of those two numbers is 15, and then the middle of those two numbers is 2. A lot of the times you can do that in your head. That's literally all we're doing. Find the middle of the x's, the middle of the y's. Now, if you want to use the formula, of course, you're welcome to. X plus x over 2, that's 30 over 2, that's 15. And y plus y over 2, that's 4 over 2, that's 2. So, of course, you can use your formula. Sometimes you can just see it, though. Now, be careful, because I thought it was kind of easy on the second one to see. I don't think it was quite as easy on the first one. So use the formula, use your brain, use both. 5C, find the other endpoint of a segment with one endpoint at 8, -20 and a midpoint of 4, -4. Now here's another one where students get super confused. Okay, if you're super confused, draw it out. This time, we're talking about a midpoint, but they give me one of the endpoints is 8, -20, and they give me the midpoint is 4, -4, but they're asking me for the other endpoint. You can still use the midpoint formula, but it's not quite the same thing as before. It's not quite as easy as before. So, to me, on this problem, it's almost easier to use the shortcut. Because what I do is I say, well, all right, this number has to be in between 8 and something else. And so if you look at what's 4 in between, 4 is in the middle of 8 and 0. It's a terrible 0. 4 is in the middle of 8 and 0. Okay, great. So then you do the same thing for the y's, and you say, well, this number right here is in the middle of -20 and something. And that's kind of hard to see what it's in the middle of. So maybe if you can't see that, I think negative numbers are hard to deal with. Maybe then you can use the formula. Maybe you can see it. But let's look at the formula first. Okay, let's go back to the x's. If I used the midpoint formula, it would be x number plus the missing x number on the endpoint over 2 equals that middle number of 4. Okay, so at any point if you see the number is 0, then stop. You've got it. Otherwise, you solve this equation. So multiply 2 times both sides, you get 8 plus x equals 8. X has to be 0, right? Subtract 8. There's no reason to do all of this work. I can see that's 0. So, it's kind of tricky because it's backwards. But what you're looking at for the midpoint is if we want this number, we'd say, all right, one of the y numbers plus the other y number over 2 is equal to the middle y number. All right. So it's kind of hard to see, I think. And so that's why I would solve it. Use algebra to solve. Multiply by 2, I get -20 plus y equals -8. Maybe it's easier to see, maybe not. Let's add 20. Y equals 12. That number's got to be 12. The answer is 0, 12. Okay, be careful on that one. It's a tough one. Number 6, total revenue of full-service restaurants in the U.S. increased from $124 billion in 2009 to $137.4 billion in 2013. Use the midpoint formula to estimate the total revenue for 2011. So notice that 2011 is in the middle of those 2 years. So all we're doing is finding the middle of those $2 amounts. That's really all we're doing. Okay. And so you get 124 plus 137.4 over 2. $130.7. and that's billion with a B.